Alrighty. In today's video, we're going to be talking about 6.2, which is exponential models, which is just a fancy way of solving word problems with exponentials. Alrighty, so a couple things just to kind of note that you might know or might not know, but just make sure you do know, is the compound interest formula is written as a sub t equals p times 1 plus r over n raised to the n t. A sub t represents total amount of money with interest applied. P is your principal amount, which is basically like um, your starting amount. So that's kind of how I like to label it as. How much money I started with. R is your rate. Usually it's given to you as a percent, must turn into decimal. All right. The T, of course, is time. It'll be given to you as ever it wants to give it to you. Year, months, seconds, days, all depends. Your N is basically amount of times interest occurs in a year. So things you might see is you might see annually. Well, let's do this in different colors so you can distinguish it. Might see annually, which means just one time a year. So this is all the N values. You might see semi-annually. And in y'all's book, it actually says it says something weird on one I've never actually seen. It said biannually. Hopefully you know that bi also means two. But in the real world, we typically use semi-annually, just means twice a year. You could also have, I believe, quarterly, which is four times a year or once every 3 months. Monthly, which will be 12 times a year because it's 12 months in a year. You could have weekly, which is 52 times. You could have daily, which is 365. And one that I don't see much, but we'll give it to you anyways, is hourly, which is 8,760 times in a year because that's how many hours there are. We don't really mess around with hour. I've seen daily. It's pretty darn close to a continuous. What I mean by that is if the function doesn't give you an n value, doesn't tell you how many times it happens a year, we have a different formula called the continuous compound formula, which is something that's recurring throughout time every second. And it's written as a sub t equals p times e raised to the rt. E is a value. Oof, I forget what the value is. It's like 1 or 2.17 or something like that. There it is, 2.71. All right. So it's not a variable, it's an actual number, just like pi is. And then P, R, and T and the A sub T all still mean the same thing. There is one last one. I'm trying to put it all on one page. And it's called the logistic curve, which is f of x equals c over 1 plus A times E raised to the negative bx. And we'll explain what all of this does, but it has to do with your transformations and stuff like that. Um, but that's what the logistic curve would be. We don't really mess a lot around with that. In the real world, at least I haven't. But it's definitely something that can be dealt with. All right, so I just kind of want to go over some different type of word problems that you're going to be exposed to on the homework so that you have a good example of almost each type. But as always, if there's more that you would like me to go over, please reach out. All right, so number 7, it says the half-life of a radium is approximately 1600 years. So half-life of radium is 1600 years. It says determine A so that A sub t equals A naught times A raised to the t describes the amount of radium left after t years, where A naught is the amount at time t equals 0. So here we go. So we have an equation, A sub t equals A naught. Basically just means the initial amounts, like your P, times little a raised to the t. And it says determine A, so we're looking for A, describes the amount of radium left after t years, where A0 is the amount of time at 0. So half-life of radium is approximately 1600 years. What else are we given? So to calculate A, what we can do is at best way to put this. In 1 year, well, I say that. Let's do this. What we can know, I know it doesn't look like there's much information, but we know in 1600 years, whatever this amount is, will be half that, right? So that means that this is going to be twice this amount. So what we can do is we can kind of figure out some variables here. We can either write this in one of two ways. We can say that if we let this be A of 0, this will end up being 1/2. Because this will end up being half of whatever that is. So let's just say radium had 30,000, right? That was the initial amount. 1600 years later, it should have 15,000, right? So that means if I was to solve this, these are completely random numbers, by the way, right? At half the life, this should end up being where I divide this first. Regardless of what numbers you choose, this will always end up being 1/2. All right, so this would total after that should be about 1600 years. Now, the issue I have, it depends on how they want us to solve it. There's real easy ways to solve this, and then there's, well, what they call the long way. Let's see. I feel like this lesson should have been after our next one that we're going to be having. But we can kind of use some of the things that we saw in 6.1 here, where I'm trying to have these have the same basis. So if I want this to look the same base, what it's basically saying that you can do is, okay, let me see if I can explain this. If I was to have, let's say we got the answer 4 and the answer was a squared, we would take the square root of it, right? If we had a cubed, we would take the cube root of it. If I had a fourth, we would take the fourth root of it, and so on and so on. So what they want you to do here, before you actually know how to solve this a lot easier of a way, this ends up actually being the 1600th root of this guy. So that means I'm going to take the 1600th root of 1/2 equals A. Now, you might not know what this is, which I mean, it'd be great if you did, but that's going to be kind of hard too. I don't know it either. But this right here could be the same thing as if I wrote it like this, or I wrote it like this, or I wrote it like this. So I can write this as 1/2 raised to the 1/1600, because that's what a rational exponent is. It is a radical written as a rational exponent, and this will be my value. So you have to pull up a calculator. So let me do that real quick. Hmm. Won't let me there it is. All right. All right, give me a second and I'll pull it up. Sure you're still seeing this. All right, do you see the calculator? There you go. Let me do a screen share here. All right, here we go. Make sure it goes through. Okay, cool. All right, so you just go to regular calculator, and all you got to do is just, you can do 0.5 if you want, or write it as 1/2. Hit this little rooftop here, and you can do 1 divided by 1600. This will give you an answer. You could have also written it as control rooftop, which allows you to actually put an index of 1600. And you could put 1/2 or 0.5 or whatever, it doesn't really matter. And you'll see you get the same answer. So these are the same equivalents. All right, so we get a 0.9. Go back to my documents. There we go. All right, cool. So again, that was 0.99. Oh, what does they want us to go to? Describe the amount of radium left after T years. Let's see, your homework looks like it was going to 6 decimals. So I want to practice that. Basically, it's what the calculator popped up with. So 999,567. All right. So that's part A, is coming up with the A. Part B then states how much of a 1 gram sample of radium would remain after 100 years. So basically what happens now is that 1 gram sample, that's your A naught, basically. So that's your initial amount. So we're trying to figure out what A of T is in 100 years. So we're looking for A of 100. Our A naught is told to be 1 gram. So we'll just write 1 gram and then times this A. So that's going to be 0.999567 raised to the 100. And you just got to plug that in. So once again, get this back over here. I sure wish it would just change automatically. There you go. All right, perfect. All right, so then you would just do 1, there we go, times, and then type this answer. I don't want to have to type that answer, so I can do control answer. It'll just bring that previous answer to me. And I'm going to raise that to 100, and then I can hit enter. Again, it was all the decimals, so my answer is pretty darn accurate there. But I can see this is how many grams I would have left. So let's pull this back up. All right, perfect. So yeah, I see it. All right, so this one, the hard part is just trying to calculate that A, but even then, the calculator will do most of it for you. So this ends up being 0.957603 grams that are remaining. All right. So there we go. So then that's that. And then part C that you'll be exposed to. It says how much of a 1 gram sample of radium would remain after 1,000 years. So again, you just do this exact same thing. I think on the homework, it only asks like one of these. And again, I'm going to share my screen. And to save yourself some time is if you just highlight what you just typed, and then this time just go back and hit a 0 for 1,000, you can get the answer that way as well, just as fast. Or you can retype it out, however you want to do that there. So in this case, this will then mean that this gives me 0.64842 grams. All right. So that's how half-life works. So it typically will always give you the equation, and then this part here can be the tricky part. But if it doesn't give you any numbers, it doesn't have to, because regardless of what numbers you plug in, you'll always get a half here. Now, best thing is if you do forget, just plug in numbers. Plug in a number and go, well, if it's half that, it's got to be this, and then kind of throw out the work. All right. So let's do a different type of problem. Let's look at number 10. This one says the population of a certain inner city area is estimated to be declining according to a model. So this will give you an equation. So P of T equals 237,000 times E. Remember, E is a number, raised to the negative 0.018 T, where T is the number of years from the present. What does this model predict the population will be in 10 years? These are the easiest questions. All you got to do is just plug 10 into the equation and get the answer. So even though they're word problems, these type of word problems are the best. All right. Where's it at? There it is. Oh, this one. All right. So if we go back over here, we would get, can make sure it's sharing. Sometimes it doesn't, and I'm just doing the work, and they're like, I don't know what you're looking at. There we go. So this would be 237,000 times your E button. There's actually one with an exponent there, but you can also pull it up from here as well. There's the E. I'm going to do the one with the exponent since I know I'm going to raise it to a power. Escape there. So I can do this and it'll automatically give me the exponent. If I go there, I would just have to hit the rooftop to make the exponent. And I'm just going to keep on typing. So negative 0.018 times, it said in 10 years. So there you go. So then your answer would be 197,959 would be the expected population for an inner city area. So again, that was 197,959 people, or population. Assume of people. It says inner city. Okay, but there you go. So that's it. All right. So let's look at a different type of question. Number 11. It says, in an effort to control vegetation overgrowth, 100 rabbits are released in an isolated area. So we'll say 100 rabbits. This is going to be my A naught or my P, depending on what I'm dealing with. Well, I'm not dealing with principles, so we'll just start with that. 100 rabbits will be released in an isolated area that is free of predators. After 1 year, it is estimated that the rabbit population has increased to 500. So that means that A of 1 is now 500 after 1 year. Assuming exponential growth, what will the population be after another 6 months? So we want to know after 1 year. So because it says 6 months, I'm actually going to say, let's call this ace of 12. And then I know that ace of 18 is what I'm looking for because that would be another 6 months. All right, so our initial equations are ace of t equals a naught times some a raised to the t. All right, so I can use some of the information I got. I originally have 100 rabbits. I don't know my A, but I know after 12 months, I would have 500 rabbits. So now we can solve this. So this is the key formula to remember. It did not give it to you this time, but it's the same setup as your half-life. All right, so I'm going to divide by 100. I get 5, ace of 12, and then you can do this in one of two ways. You can just say this is 5 raised to the 1/12th, or you can do the 12th root of it. Either way, you'll get the same conclusion. So let's type this into our calculator real quick. It'll be quicker, but we got what we got. All right, so again, perfect. All right, so this again would have been 5. All right, raised to the, was it 1/12th? And you get 1.14353. While it's on my mind, you could have kept it in years, and just said a to the 1 as well, which might have made it easier, because it would just been 1/5. But then when you go back and plug it in, you'll be looking for 1.5. So I don't know. I don't know. My first thoughts go to months. Um, but you could have kept it the other way. So I'll kind of show you both. You can kind of pick which one you like the best. Anyways, I got an answer of 1.14353 as my A. So when I'm looking for this 18 months, I would just say, all right, ace of t now equals 100 rabbits times this 1.14353 raised to the 18 this time. And I just want you to see that we could have done the same thing if we would have gone this route as well. So I could have done ace of t, but or here. And this will give me 100. If this would have just been 1 year, then this is obviously would just been A, so the answer would just been 5. So I could have said 5 and then raised that to the 1.5. Maybe this one's easier. I don't know, this is where my brain went, but you can kind of see both and I'll show both. Many ways to get to the correct answer. It's the beauty of math. All right, so when I'm over here, I would need to do 100 times, in my case, I'm going to do control answer, and then I'll raise that to the 18, and I get this as an answer. If I did it the other way, I could do 100 times 5 raised to the 1.5. And you can see you get the same conclusion. So you can keep it in years or keep it in months. Just make sure your time frame stays the same. But my brain instantly went to months. But had I looked at it maybe longer, I would have probably kept it in years. But again, regardless, so that's going to be, obviously you can't have part of a rabbit. So the way they want you to kind of round this is, I believe they always want you to round up. Let me make sure. Oh no, they just expect you just to round. So it's round in general. So that would be 1,118 rabbits. So that 0.03 would kind of just be thrown to the side. All right, so there you go. So that's that type of problem. Let's look at a different type. Let's look at number 12. It says, assuming a current world population of 7.75 billion people. So this will probably be our initial amount, 7.75 billion. As long as we write the word billion in our answer, we don't have to write all the zeros. Of an annual growth rate of 1.9% per year. So growth rate would equal 1.9%. This is my A. I just have to write it as a decimal. So to do that, you just move the decimal to the left 2 places. So this becomes 0.019. So again, you just move it 2 places, go from percent back to a decimal. So 0.019 would be my A. And a worst case scenario of an exponential growth what would be the world population in 10 years and 50 years? All right, so here we go. So we originally have this as our equation. Where you have your initial amount. But this is technically going to be your 1 plus r here, raised to the t, where the rate, since it's a growth, I'm going to add. Had it been a, I don't know, a decay or something, you would subtract. So to plug all this in to figure out what we need, part A wants us to find it in 10 years. So my original value is 7.75 raised to the 1 plus 0.019 raised to the 10, right? So there's a couple other ways you could do this. Some people teach it as they'll find out what the interest rate is, a 0.019, and then go back and add it to 7.75. There's nothing wrong with that. In this situation, this allows you to get the grand total all at the end rather than having to do it in multiple steps. All right, so let's make sure we did this right. So we'll come over here, plug it in our calculator. And again, that was 7.75 times, I'm just going to say 1.019 because that's what that's going to add up to, raised to the 10. And you get 9.3459. I think on the homework, they just have you rounding to the hundredths place. All right, so therefore this would be 9.35 billion. Part B just has you do basically the same work again, but this time at 50. So ace of 50, 7.75, 1.019 raised to the 50. So again, I'm just going to come back over here. And again, I'm just going to copy it so I don't have to retype it and then turn it into a 50. And there's my answer there. So that's going to be, again, the rounding to the hundreds place. So that's going to be 19.86 billion people. All right, so that's kind of how you do those. This is basically when you're adding or subtracting a rate from your 1, which would be that whole amount. All right, let's look at number 13. It says Medea. I see Medea with an H. Medea. We'll call her M. M has $3,500 that she wants to invest in a simple savings account for 2.5 years. We'll do years this time. At which time she plans to close out the account and use the money as a down payment on a car. She finds one local bank, call this number 1, offering an annual interest rate. So that means the N would be 1 because it's annual. The rate would be 2.75%, turned into a decimal would be 0.0275. Again, move that decimal 2 places to the left. Oh, I got distracted. Annual interest rate of that, but it's compound monthly. So that means N is 12. And another bank offering, we'll call this bank number 2. Another bank offering of an annual interest rate of 2.7. So here's my N, here's my R. So 2.7% would be 0.027 compound daily. So that's 365 times per year. Which bank should she choose? So using that compound interest formula we looked at the very beginning, which is A equals P times 1 plus R over N raised to the NT. I want to plug everything I know. My principal amount was $3,500. So this is my P times 1 plus my rate for this one is 0.0275 divided by 12, which is my N. And then this will then be 12 times, she said 2.5 years. The other equation, so that we can have both and we can just plug them both in, will be 3,500 times 1 plus 0.027 divided by 365. And this will be 365 raised to the 2.5. So we'll plug in both and we'll basically just see, hey, which one gives us the greatest yield? And then that will be the bank that we choose. All right, so here we go. We go to our calculator. All right, and that was 3,500. Where's the question? Times, I'm just going to keep it all together as 1 plus, so I got to do the math as well. 0.0275. I like to do control divide to make it look like a fraction. There we go. 0.0275. That was divided by 12. Then I'm going to hit my rooftop here. This was then going to be NT, so that'd be 12 times 2.5. And so there's that money, and I'm just going to copy and paste and just change the numbers that need to be changed. This is now going to be a 0.027 at 365 days. And then this is 365 days for 2.5 years. And there you go right there. So we can actually see that the better bank is the one at 2.75% compound monthly. So this will be our winner. So this was $3,748.79, where this was $3,744.40. So bank one, oh, I don't know what I'm spelling there. Bank one is the better deal. Now it's only like a $4.39 difference, but more money still means more money. All right, so there you go. So that's that type of problem. So let's look at a different one. Let's look at number 18. 18 says, given the inflation model, so it gives us a model, so C of t equals C of 0 times 1 plus r raised to the t. And given that a loaf of bread that currently sells for $3.60 sold for $3.10 6 years ago, what has the average annual rate of inflation been for the past 6 years? So we're looking for our r. So here we go. So our initial amount, so C of 0 would be $3.60. The C of t, the new amount, is $3.10. And then we're given 1 plus. The R is what we're trying to calculate, and it said 6 years ago. So here we go. So we'll start off by dividing. We're just going to do some quick math. I'm not going to jump to the calculator, but that's 3.1 divided by 3.6. That gives us 0.861111. 1 plus r raised to the 6th. So that means I want to raise this to the 1/6. So that will go away. So now I got 1 plus r. So I'll just, in your calculator, if you already did 3.16 divided by 3.6, just highlight that number and then raise it to the 1/6. And when you do that, you get 0.975386. And then we'll subtract 1 from that. So we'll just say -1. It'll take the previous answer when you do that. And then we see that that's going to be negative 0.024614, which is my R by subtracting 1. All right, but we want the rate. So that means that's going to be 1, 2. That's going to be a 2.4614%. But I just want you to round then to the nearest tenth. So this will be 2.5%. Right? And that's a decrease of inflation or deflation or rate of inflation. There you go. Has decreased by 2.5%, which would be great if we saw that in our grocery bill. All right, so then that's it. Again, quick, just look at over here so you can kind of see what I did. I basically, again, I took 3.16 divided by, or 3.1 divided by 3.6. I got this value. I controlled an answer here of 1/6. It got this answer, and then took that answer minus one and got this answer. So that's just right there, some calculations. All right, so then we'll look at number 19. All right, number 19 says the function n of t equals 10,000 divided by 1 plus 999 e to the negative t. So it gives us a function. It says small is the number of people in a small town who have caught the flu t weeks after initial outbreak. Part A says how many people were ill initially. So that would mean what's n of 0. So this ends up being 10,000 divided by 1 plus 999 e to the negative 0, which basically makes this 1. So this plus that. So this ends up being 10,000 of 1 plus 999 times 1. Then this is, hopefully you can see at this point, that's 1,000. Delete, delete, delete. 10. Right? So 10 people initially caught the flu. Just an FYI, you could have just plugged it straight in the calculator, got the answer. But when there's math, that can easily be done. It's so much better just to do it by hand. All right, part B then just says how many people have caught the flu after 8 weeks. And this model is T does represent weeks, but do watch out for that. I could have said weeks and then T is in months. So you would have to change 8 weeks into 2 months because we represent 4 weeks in a month, give or take. So here we go. So that would be then what's n of 8. This time I'm not going to try to do it by hand because that's going to be a big old fraction. So let's switch to our calculator. And so again, that is going to be, we'll go ahead and do control divide. So this would be 10,000 divided by 1 plus 999 times the e, which is right here. Again, I choose the one with the exponent, so I can just say negative 8. And we get 700 or 7,489 people now have it. So after 8 weeks, we now have 7,000. I think they just want you to round in general. Yeah. So this would be 7,490 people have the flu. Part C then says, determine what happens to the function as t approaches infinity. So anytime you get these type of questions right here, the answer will be n of t equals c. Your c is this guy right here. You cannot go more than that value. That means that this model means that as time goes on, the most people that will get the flu is 10,000 people. Alrighty, let's see. So there was a type of problem like this one. Let's look at number 23. It says Marshall invests $1,200 or $1,250 in a mutual fund which boosts a 5.7% annual return, compound semi-annually. So that's what you typically see. So that biannually really threw me off. Semi-annually, which is 2. After 3.5 years, Marshall decides to withdraw his money. So time is 3.5 years. How much is in his account? All right, so here we go. So this is compound. So this is going to be ACE of 3.5, which in this case will be 1250 times 1 plus your R. So remember, this is your P, this is your R, that's your N, that's your T. But I got to turn this into a decimal. So that's 0.057. So it's going to be 0.057 divided by 2. And then this is going to be 2 times 3.5. Just that part A there. So let's plug that in. So then over here, we would write, well, 50 times 1 plus, again, I like to do control divide, 0.057 divided by 2 raised to the 2 times 3.5 years. Yep. And there we go. So when we come back, he made $1,521.74. Then it says part B, how much has he made in interest from his investment? So all you got to do is just do 1250 minus 1521. Oh, I bet the other way around. So it's be 1521.74 minus 1250. So real quickly, do some calculations. And he made approximately $271.74. Ain't no more parts of it. All right, so there you go. And that's it. Just be able to use the formula. Another question I saw was like number 24. Says Adam is working in a lab testing bacteria populations. After starting out with a population of 375 bacteria, he observes the change in population and notices that the population doubles every 27 minutes. So doubles in 27 minutes. All right, part A then says, all right, find the equation for the population P in terms of time T in minutes, rounding A to the nearest thousands. So here's the initial amount. All right. So what I can do is to figure out what this A is, I can say, well, actually, that could just be 375. Oh, wait, yeah, to find out what the A is, in 27 minutes, this doubled. Ooh, this doubled. So real quickly, 375 times 2 is 750. So to solve this, I can simply just divide. And really and truly, again, just like beforehand, since I knew it doubled, I should always get the answer of that. And then now I can just do 1 to the 27th of that. And I've done this a couple of times, so I don't think I need to show it again. But again, that'd be 2 raised to the 1 divided by 27. And I get 1.026. So therefore, your equation is A of t equals 375 times 1.026 raised to the t. So that would be your equation. And again, it said thousandths place, so that's 10, hundreds, thousands. I gave us a clean number, so we don't have to stress much about it. And then part B just says find the population after 2 hours. So that would be 120 minutes. This is 3.75 times 1.026 raised to 120 minutes. So again, because it says 2 hours, but our formula is in minutes, we just got to do a little conversion. So let's check it. You can kind of see, again, the 2 to the 127th is what we got there. So this again was, where are we at? Number 24. So that's 375 times 1.026 raised to the 120. So there you go. So then I get the answer of 8,160 bacterias. Alrighty, let's see. Another type of question I saw was like number 27. Says if $2,500 is invested in a continuously compound certificate. So the word continuous means I'll be using a PERT. Continuously a certificate. So again, this would be our P. Deposit with an annual interest rate of 4.2%, which will be 0.042. What would be in the balance in the account after 3 years? So time equals 3. So now we just got to plug it in. So as this 2,500 E, remember that's a number, raised to 0.042 times 3. So we go do that real quick. So again, we have 2,500 times E raised to the RT, so that's 0.042 times 3. There you go. So this will give us $2,835.71. All right, another question I saw was like number 31. And this will probably be the last one I'll have time for. I think that's pretty much all of them. I think there's a couple with a table, but you just pull the information just like we've been doing from the rest of them as well. All right, so number 31 says depreciation is the decrease of an item's value and can be determined using a formula similar to that for compound interest. So they got V equals P times 1 minus R raised to the T, where V is the new value. If the particular car you buy upon graduation from college cost 17,500, so that's my P, and depreciates at a rate of 16%, so that'd be 1 minus. Remember, 16% has to be written as a decimal, so that's 0.16 per year. What would the value be in the car after 5 years? So there's your equation. All you gotta do is just go plug it in. So this will be the last one. Again, make sure I'm sharing. Okay, so this would be 17,500 times parentheses 1 minus 0.16 rooftop, 5 years. So your $17,500 car is now worth $7,000. So it'd be worth $7,318.71. All right, so again, that's all I got time for today. Again, if you ever need any more help on them, just reach out. Until the next video.